Hello, welcome to Algebra 2. Go ahead and turn your books to that lesson, lesson 67, and we'll go ahead and begin. This is in continuation of all your trig lessons. Make sure you have the book in front of you, and the homework will now be on the computer because we need to enter in grades. We don't know how long we're going to be here. I need weekly grades, so we're going to have the quizzes that you used to have. They will now be homework assignments. And on Monday to Thursday, you'll have a lesson and homework. And on Friday, you'll have a quiz over that week. So that will be the routine for now on until we come back to school, until I see you guys again. Here, let's go ahead and do our trigonometry lesson. We have inverse, not reciprocal. Reciprocal functions are the secant, cosecant, and cotangent. These are inverses. So we have the inverse of sine, cosine, and tangent. Here, we're going to go ahead and describe all the values of this inverse of sine of radical 3 over 2. To find this, they want this all in terms of radians for now. So in terms of radians, we're going to go ahead and look for the sine. We always know that the sine is considered the y-coordinate. On the top here, if you have it, I don't remember if I put it on your paper or not, you have this. It's x comma y, or it's cosine comma sine. Sine is your y-coordinate, cosine is your x. Tangent is y divided by x, or sine divided by cosine. Here we're going to look for radical 3 over 2 in the graph. There are actually only two possible degrees where the radical 3 over 2 is in the y coordinate, and that is 60 degrees and that is 120. So if you look at 60 degrees and 120, they have a positive radical 3 over 2. But we're going to be looking at it in terms of radians. So it's going to be 60 degrees is radians over 3, and then 120 is 2 radians over 3. These are our two main things here. Number one is finding all the degrees of radical 3 over 2 in the sine position, or in the sine coordinate, which is y. And that's only two possible answers. Two, we're finding all values. So remember, this graph is only from 0 and 360, but there are multiple answers, keep on going, 720 and on and on and on. There's infinite number of type of degrees. They're called coterminal angles, meaning when you add 360, when you subtract 360, there are so many different answers. Here they say they want you to find all the values. When you're trying to find all the values, you're going to be adding by 2 radians, or you're also going to be multiplying it by n, meaning it could be 2 radians, but we could do by -1, by 2, by 3, by 4. Instead of just adding 360 every time, plus 360 again, plus 360 again, we can just multiply 360 times 2 and we add into this. So whenever you're trying to find the values, I put here, just add plus 2 radians n. And this tells you there's infinite numbers of, there's actually coterminal angles of the 60 and the 120. So you keep on going around and around, or backwards with the negatives, around and around. These are your two type answers. Example 2. Here we're trying to find the inverse tangent, but now we're going to deal with domain and range. Here we have the graph. In the book they have a picture of where, like in the shaded area, where sine and cosine and tangent, where it's positive. So here, the inverse sine, so only dealing with inverses. The domain is between -1 and 1. The range is between -90 and +90. Cosine, the inverse cosine of A, domain is -1 and 1, but it's between 0 and 90, so it's positive. Inverse tangent of A, the domain is any set of real numbers, so it could be 7, it could be 10, it could be 11, but sine and cosine, there is a certain restriction for it. For the range is between -90 degrees and +90. We're going to be using this graph to help us with example 2 and so on. Example 2, they tell us to find each inverse trig function a value that exists, and give an answer both radians and in degrees. So here we have inverse tangent of -1. You're not going to be looking at your unit circle anymore. We're going to first look at this up here. I'm going to write it in terms of regular tangent. So for -1, first we have to see if it abides here. So for here, the tangent of A, the domain, this is considered a domain, -1, that means we can have any type of real numbers here, so -1 is okay. Now, tangent, what it means is y divided by x. When you're dividing, especially complex fractions like what we have here, because it's a fraction over a fraction. When you're dividing, you're trying to find an answer where you get -1. And if you look in your graph, it's only alongside this grid over here. It has to be between -90 and 90. We're trying to find a degree that abides by this principle over here. So it's -1, that means we're okay to go. Here, we need to find an answer. If we divide the tangent, we will get -1. So we're only looking at this side because that's what the graph has on your book. It's also between -90 and 90, which is only this half of here. So if we look around here, let's see, starting at 0. So it's actually this side. If you divide this, you'll get a complex number. Divide this, you'll get +1. So if you divide the same number by the same number, 4 divided by 4, you get 1. Same thing with complex fractions. This equals 1. This gives you a complex fraction. Complex fraction. Here, one number divided by a negative of the same number gives you a -1. So that means our solution here would be 315. But we have to look at our range. Our range tells us it has to be between -90 and +90. There are two ways we can find this. We can go ahead and find the coterminal angle, meaning go ahead and subtract by 360. You will end up with -45 degrees. Or if you look at 315, what I like to do is I look at 315. If I'm trying to find the coterminal angle for that one, all I do is count from the number from the 0 from the origin. So it's 2 number lines away from here. It's 2 number lines away here. It's going to be a 45 there. So when you subtract by the 360, you're going to get -145. So it's this same mark here, but it's in negative degrees. So that means your answer is going to be -45 degrees, or it's going to be negative radians over 4. All you have to do is just look at 45 degrees, and 45 degrees is radians over 4. Or you can do the math, what we did from the previous lesson, and shows you how to convert from degrees to radians. But these are your two answers here. So it's a lot of relying on this range here. It's not 315. We can't use 315. It has to be between these two. Next one, B, the inverse cosine of 2. If we look at our domain, because this number is dealing with our domain, cosine has to be between -1 and 1. Here we have the inverse cosine of 2. In this case, the inverse cosine of 2 does not exist. So therefore, you don't have any answer there. I spelled it wrong. Exist. There's no answer, no solution. You can put whatever you want. Again, in your homework, I always look back at your problems and I try to fix it. So if it's wrong and it marks it with an X, I go back and give you the full credit. Sometimes the form will be off by just a space or even by just one extra symbol. Again, I always look back on these lessons. Example 3. Now we are solving for these type of equations, which you will see quite a lot. We have 2 cosine theta of radical 3 between the limits of 0 and 360. The direction says solve for that. So we're finding any possible degrees for this here. Just like you're solving for x, you're going to be solving for each of these sine or these trig functions. To get cosine by itself, you divide by 2. So then you have the cosine of theta is equal to radical 3 over 2. If you look in your chart, which you will need, you're looking for the cosine of radical 3 over 2. It's a positive one here. So if you look at your chart all around, cosine is considered your x. That will be, just to make this faster, that would be 30 degrees. If you go back around, this is negative. It does not count. We need a positive. So 30 degrees. Here says name any from 0 to 360. So the first one is 30. If I keep going back around, it looks like I have another one here at 330. And we stop there. So if they don't tell us a limit, we'll keep on going and going and going. But here we're trying to find degrees in which we solve for this equation between 0 and 360, which is 30 and 330. Keep in mind it's a positive. Always look at this when you're dealing with your unit circle. Next one, 5 sine theta equals 5. You're solving for your trig function and you're finding degrees between 0 and 360. If I divide 5 on both sides, I get the sine of theta is equal to 1. We're trying to find where sine is 1. We're trying to find the degrees where sine is 1. If we look at charts, sine is considered your y coordinate. That would be here. And that degrees is 90 degrees. If you go back around, all here, you have this here, you have this here, it has to be a positive 1, and that's only 90 degrees. C, here we have to solve for this, but they want it in terms of radians, but they want all the real numbers. That goes back to example 1, adding the plus 2 radians n. Here, we have to solve for sine first. So we divide, there is an equation here. You can't really get x by itself until everything is removed off. So just like trig functions, it's not completely by itself on one side. Subtract 3 to both sides. You get 6 sine theta equals -3. Then you divide by 6. Then you get the sine theta of -1/2. So you have your -1/2. You're going to be looking for sine, which is your y coordinate, where it is -1/2. And just to save the work, I have 2. I have 7 radians over 6, and then I have 11 radians over 6. Both of those have the coordinate. They have the they have the y with a -1/2. You're only looking from 0 to 360, but now they want it in terms of all real numbers. That means we want a infinite number of answers. So you have your numbers here, just like example 1, just add plus 2 radians and plus 2 radians n. Because this expression tells us there are infinite number of answers if we keep on adding 360, 360, 360. Same thing here. Or -1, if we multiply by -1, you're subtracting by 360, 360, 360, and so on. One more example and then we're done. 10 times the cosine theta of 6. Here we are solving for these different type of problems. We actually want to find what this degree is. Here we're just finding certain degrees, what it could be, but we're finding the exact degree here. So what we do, also because this is not in the unit circle, that means it goes beyond the unit circle, therefore we have to rely on our calculator. Here, to get cosine by itself, you divide both sides by 10. Cosine of theta is equal to 3 over 5. To simplify that fraction, we're trying to solve for this. We know 3/5 is nowhere in the unit circle. That's where you have to bring your calculator. To get the theta by itself, you have to get rid of the cosine. To get rid of the cosine, you have to multiply by the inverse cosine to both sides. That cancels out the cosine and the inverse here, and you get theta by itself on one side. Now you have the cosine, the inverse cosine of 3 over 5. And that is what you can plug into your calculator. So if I have in my calculator, so the inverse cosine, so it's second cosine of 3 over 5, we get 53.130. Be careful of having your calculator in radians and in degrees. I would recommend just putting in degrees for now because we are looking for the actual degrees and not the radians form. Here they want us to factor out, so then I get about 53.1. This lesson is very important in trigonometry. This will help us a lot more when we deal with more advanced stuff. Take it step by step, do your homework, and miss you guys. Have a good day.